In this video, we're going to take a little closer look at the absolute value family functions. Here we have the absolute value parent function. The parent function is the most basic function in a family. Functions in the same family are transformations of their parent function. So here, when we see f of x equals the absolute value of x, that's the most basic this function can get. But we can do things like add to it, multiply, subtract from it, and those would be transformations. Let's look at how those transformations can be affecting our graphs. Or rather, how those transformations affect our function. Notice that the vertex of our parent function starts at 0, 0. Here, we see all the different changes that could happen to our parent function. So what do all of those mean? Here we see that if we have an h value, that's going to change the direction the graph moves, either left or right. Surprisingly though, it's not how you would think. When we see a -2, that actually tells us that our graph is going to shift to the right 2 places. If we were to see +3, then it would move to the left 3 places. And that's because in our original equation, we have a minus sign already there. So in order for the minus sign to stay there, our 2 has to actually be a +2. And for our 3 to turn into a +3 in the equation here, that means that the 3 would have to be a -3, because we know that when we take a negative and subtract it from something, we're really adding. So what happens when we add or subtract something onto the back or the front? Well, when that happens, our graph is either going to move up or it's going to move down. So in this case, our graph is going to move up 1 spot, or down 1 spot rather, and up 7, because here we have a +7, so it will move up. And here we have a -7, so it will move down the 1 space. So what about those negative symbols? Well, it really just depends on where that negative symbol is. Is the negative on the inside? Is the negative on the outside? Those are going to be reflections. So when our negative is on the inside, we're going to reflect across the y-axis. And when our negative sign is on the outside, we're going to reflect across the x-axis. When we have a number being multiplied by our x on the inside of our absolute value symbols, that's either going to stretch or shrink our graph horizontally. So think about pulling it away from the y-axis or squishing it towards it. So when that happens, we have a horizontal shrink when we're multiplying by a 3, and that's going to shrink our graph by a factor of 1/3. And when we have a 1/2 or a number smaller than 1 being multiplied with our x, that's actually going to represent a stretch by a factor of 2. Now it seems kind of weird that anytime we do something to the inside, it's the opposite of what we think. But I like to think of the h as a hypocrite, where it says one thing but does another. So that might be an easy way to think about it. So what about if there's a number on the outside? What about if there's a number on the outside, being multiplied on the outside? How is that going to affect our graph, our function? Well, this is a lot easier because it says what it means. So here, with the 4 on the outside, we'll have a vertical stretch by a factor of 4. Now, a vertical stretch is when we either stretch away or shrink in, get kind of squished down towards the x-axis. So if we have a 1/5 out front, that would give us a vertical shrink by a factor of 1/5. These transformation rules don't just work for absolute values, but lots of different parent functions. They work for linear functions. They work for absolute value functions. They work for square root functions. They work for quadratic functions. They work for cubic functions. And they work for rational functions even. And some more. So keep that in mind when you're trying to decide how a transformation affects a parent function.